Hi everyone. So today let's solve the problem 63 unique paths 2. We have already solved the unique paths 1. Just this one. The last problem was unique paths 1 itself, right? So let's solve the unique paths 2. So let's see what the question states here, man. So given an m into n, great. So we have been given an so look at the diagram, man. They have clearly mentioned here. We have been given a m into n grid. Here in this case it's 3 into 3, right? So you can, by looking at it, you can just say here, right? Given an m into n grid with a 0 as empty cells. So 0 represents empty cells here, right? So I'll just write here empty cells. 0 represents empty cells and 1 as obstacles. 1 are obstacles, right? So 0 represents empty cells and 1 represents obstacles, right? So we need to return how many unique paths exist from top left. Top left is nothing but this one, where android symbol, this one is present actually. This is right. Yeah. Now we have to return how many unique paths exist from the top left, nothing but the 0, 0 to the bottom right, nothing but this one, the last one. So this is represented by m minus 1 and n minus 1, m minus 1 and n minus 1, right? When you can only move right or down, when you can only move right or down, right? So let me say this one again, just listen to this carefully. We have been given an m into n grid, right? So here in this case, let's consider the example 3 into 3 grid, yeah? With 0 as empty cells and 1 as obstacles, with 0 as empty cells and 1 as obstacles. So this one indicates 1, this one indicates 1, and all the cells are empty basically, right? Other cells are empty basically. Yeah, we have to return how many unique paths exist from top left, nothing but the first one, 0, 0. So this is 0, 1, right? So this is 0, 2. So this is 1, 0. Let me represent this one, 1, 1 and 1, 2 as well. So this is nothing but 2, 0, 2, 1. So this is nothing but 2, 2, the final one, final cell. Yeah. Now we have to return how many unique paths exist from the top left 0, 0 to bottom right m minus 1 n minus 1, when we can only move right or down. If a cell is an obstacle, it cannot be a part of the path. If a cell is an obstacle, then it cannot be a part of the path. So answer is guaranteed, and it has to be less than or equal to this one, 10 into 10 to the power of 9. So that's what they have mentioned in the constraints, right? So here, this is the question, man. Yeah, this is the question. Yeah. So we have to return how many unique paths exist from top left to the bottom right, nothing but from 0, 0 to m minus 1, n minus 1, right? When we can move only right or down. So this one is very important, right? And also one more criteria, if a cell is in the obstacle, if a cell is an obstacle, then it cannot be a part of the path. It cannot be a part of the path, right? So just remember this one. Yeah. Now let's do one thing. Let's do one thing. Um, yeah, let's discuss the approach followed by the complexities and then let's write the code. Yeah. So here obstacle grid, we have been given 000 010. Before discussing the approach, let's go with the example. See here 00001 010 000, right? So initially it's 0, will be starting from here 000 0. This one obstacle we are having 0. Sorry, initially I said this one as 1, right? I thought this one as obstacle within the question. I'm sorry, just consider this one as 0. This is just the symbol, starting symbol that I have given, right? So this is 0 0 0 as well. Yeah, sorry. Yeah, this is fine. There is one obstacle in the middle of the grid. So this one is the obstacle. So this one is the obstacle basically. Yeah. Now, there are two ways to reach the bottom right corner. One is this one. Go right, right, then take this one down, down, right? So that's what they have mentioned here. See, so from here, the guy will start from here, or the robot will start from here, right one step, this one, down one step, finally down one step. So we will be reaching m minus 1 and n minus 1, or the last cell. This is one way. Or we can just go with down one step, down one step, right one step, and right, right, down, down, right, and right. This here in this way also we can just reach the last cell. These two are the valid ways. So these two valid ways we have to return valid ways, right? So here in this case we have to return 2. We have to return 2, right? So same goes with the next example. They have given another example here, haven't they? Yeah, they have given here, right? Now, this one also same, man. See here, there is only one way here. This one, down, next right, down and right, right? Down, right. So we, in this case, we have to return one. There is only one valid way, right? So this is fine, I believe. They have given us wonderful examples. Just with the help of the figure itself, we can just this one. Get the question as well as the answer part, right? So this is fine, man. Let's do one thing. Now let's discuss the approach followed by the complexities, and then let's write the code. As I've said, first thing, so we will be going with a dynamic programming to solve this particular problem, right? So we can just go with a 2D DP to solve this particular problem easily, right? First, let's discuss the approach step by step. The first step here, what we will do, we will build the DP table same size as the grid. So here in this case, the first example, let me come here. Just give me a second here. Let's consider the first example, this example itself for the this one. What do we call? Approach actually. Yeah, first what we will do here, we'll be making use of the DP. First, what we will do here, so we will build the DP table same as the grid, right? So I can just represent this one in this way. DP of ij is equivalent to the number of ways to reach the cell I comma j, number of ways to reach the cell I comma j, right? So I can just represent in this way. First step. Next step, let's fill the first row, right? So this one, first row, accordingly with the first example, this one, right? So this one, let's fill the first row. DP of 0j is equivalent to the DP of 0j. If it is equivalent to the 0, then we can just display DP of 0j minus 1. Else we can just go with this one. What do we call? 0, right? So I'll just write it in this way, man. See here, I can just represent this one in this way. DP of 0j here. So if it is equal to this one, let me consider grid G, right? I'm consider grid this one as G. G of 0j. If it is equal to 0, then let's display dp of 0j, dp of 0j. Uh, else let's display 0. Else let's display 0. Here obstacle kills that cell and all to its right in the same row, right? So just remember this one. Yeah. And so we'll start with dp of 0 0 equals 1 if the grid 0 0 is 0. If grid 0 0, otherwise we'll be displaying 0, right? So now one more step I forgot here before this step, second step. So we will be starting with this one base case actually. dp of 0 0. Just remember this one as well. This is very important. dp of 0 0 is 1 if dp of grid 0 0 is 0, otherwise it's 0. Otherwise it's 0. Just remember this one. Yeah, let's move on with a further step. So this is base case, man. Yeah. Now, let's move on with the next one. Next step actually. We have to fill the first column similarly, right? So we did this one for the first row. We have to fill the first column, this one similarly, right? I'll just write here. We have to fill the first column similarly here, right? So this is fine. Let's move on with the last step here. What we will be doing, let's try to implement the same thing, right? For each inner cell ij, if it is obstacle, then dp of ij is 0. Else dp of ij equals dp of I minus 1j plus dp of ij minus 1. We know this one. Let's try to apply the same thing to the example. First row becomes here, accordingly with what we have discussed, first row becomes 1 comma 1 comma 1 here, right? First column also becomes initially, and first column also becomes 1 comma 1 comma 1 initially as per the approach that we discussed, right? So at 1 comma 1, at 1 comma 1, obstacle is 0. At 1 comma 1, this one, at 1 comma 1, obstacles, we can just mark this one to 0, right? So rest we have to compute, right? So we will go with a bottom right, basically bottom right. dp of 2 2, we will get the last one, we will get bottom right, this one as 2, the solution 2, this one actually 2 to 2 comma 2 actually, right? Rest we will compute. So we'll get but the bottom right, we will get the value 2. So the output that we got here is 2, which is equivalent to the output that they have mentioned for the example within the question. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities. So what will be the time complexity here? The time complexity would lead to big of m into n, right? So the time complexity would lead to big of m into n. So what would be the space complexity here? The space complexity would lead to big of m into n as well, right? So the time complexity would lead to big of m into n, and the space complexity would lead to big of m into n respectively, right? So now, why it is a big of m into n time complexity? We will be visiting each cell once to compute the dp, right? Overall time complexity would lead to big of m plus n, m into n, and the space complexity is big of m into n because we'll be going with a 2D dp array of the same size as the grid, as the grid, right? So overall space complexity would lead to big of m into n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach and the complexities, let's start writing the code. Initially, what if grid is null? There are no paths at all actually. Then we have to return zero, right? Let's write the same. If obstacle grid, let me copy this one. Obstacle grid, if it is equal to null, then in that case we have to return zero, right? So let's go with the number of rows first. So let me initialize m2 obstacle grid dot length. So this is fine. The second step here would be, let's go with a guard, nothing but empty grid to no path. So this one will be if m equals 0, then we have to return 0 as well. So let's go with the we have to go with the number of columns as well. The same steps, man. Number of rows, then we have to go with the guard, nothing but empty grid, no paths. Here number of columns, then we have to go with the guard. 0 with this one, nothing but 0 with grid, then no paths, right? The same thing. So let me copy paste the same thing and make the necessary changes here. So this one, write it over here in this way. So we are considering columns, it has to be n, and here for the column I'll just go with obstacle grid of 0. This is fine. Dot length, this is fine. And instead of if m equals 0, I'll just go with if n equivalent to 0, then we have to return 0, right? So this is fine, man. Yeah. Now, as I've said, we'll be going with a DP. We'll be making use of the dynamic programming. Let's initialize here. Let's initialize the DP array to this one. New int of this one. It is same as the size this one, right? Grid actually, m into n we have to consider. We are just creating the DP array, 2D DP array basically, just to store the ways to each cell, right? So simple one. So we are just articulating the same thing in the form of code that we had discussed earlier in the approach. Now let's initialize starting cell. When I say let's initialize the starting cell, if there is an obstacle at the start, then number of ways is equivalent to this, it will be equivalent to 0, else it will be equivalent to the 1. We had discussed this one in the approach. Let's write the same thing here. dp of 0, 0. Let me go with here. Sorry, this one, let me copy this one now. Obstacle grid, yeah, of 0, 0 we have to consider, right? Initially. So this one, if it is equivalent to the value 0, then we have to display 1, else we have to display 0, right? So sometimes this ternary operator, it will be very handy, man. Yeah, it reduces a lot of code actually. So this is fine. Let's initialize the first row here. When I say let's initialize the first row, each cell is reachable only from its left neighbor. We know this one, right? So I'll just write it on this way. For int j equals 1, j less than n, j plus plus. So here let me write one if condition, simple one. If obstacle grid of 0 and j, if it is equivalent to 1, then meaning if the current cell is obstacle, then we cannot stand on an obstacle, meaning so this one will be dp of 0j. So this is equivalent to 0, right? Else what we will do, else what we will do, so I'll just go with a dp of 0j. uh, dp of 0j is equivalent to dp of 0 j minus 1. Yeah, this is fine. Else we are inheriting the ways from the left. It could be 0 as well. So let me come out of this one entirely. Now let's do one thing. Let's initialize the first column. Each cell is reachable only from the cell above, right? So I'll just go with a for loop here. So this one int I equals 1, I less than m. So this one will be I plus plus. So this is fine. Within the for loop, if the current cell is obstacle, then we cannot stand on the obstacle, right? So I'll just right here, if obstacle grid of I 0, we just have to articulate in the form of code. If it is equivalent to the 1, nothing but the, if the current cell itself is the obstacle, or it consists of the obstacle, anything is fine, right? So then, yeah, then what we need to do, we cannot stand on that particular obstacle, right? So I'll just initialize, or I'll just assign dp of I0 to 0. This is fine. Else what we need to do here, else we have to inherit the base from above. It could be 0 as well. Yeah. So this one will be dp of I0 equals dp of I minus 1 and 0. Yeah. Now let me come out of this one entirely. So let's fill the rest of the dp table, man. We are left with filling the rest of the dp table. Let's go with the two for loops here, as we are going with the 2D dp, right? So this one will be int I equals 1, I less than, first rows we have to consider. Then let me increment this one. Next we have to consider columns, right? So for int j equals to 0, j less than n, j less plus. Yeah, this one has to be 1, I believe, not 0. Yeah, sorry. Yeah, within this for loop. So if this cell is an obstacle, then no ways to reach an obstacle cell. We know this from the approach, right? So how can I write this one in the form of code? If if obstacle grid, this one of I j, if it is equivalent to 1, then let's do one thing. dp of I let me assign this one to the 0, right? Else what we need to do, else what we need to do, uh, we have to sum ways from top and left. So this one will be dp of I j, this one will be equivalent to the dp of I minus 1 j plus dp of I. So this will be j minus 1 as well. Yeah. Now we went with summing the ways from top and left. Addition stays within the int, because this one, the problem guarantees that it is less than or equivalent to the 2 into 10 to the power of 9, right? So now this is fine, man. Finally, we are left with only displaying the answer, meaning answer is ways to bottom right cell. So that is nothing but dp of m minus 1 into n minus 1, as we are going with the 2D dp, right? So come here. So we have to return dp of m minus 1 and n minus 1 respectively. Right? So this is fine, man. Let me format the code once and let me hit the run button. I hope this works for all the test cases. Let's see. Yeah, let me hit the submit button. I hope this works for all the test cases. Yeah, yep. Uh, whatever the code that we have written works absolutely correct for all the test cases. Yeah. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.